Now, glycolysis is therefore a series of reactions that extract energy from glucose by splitting it into two 3-carbon molecules called pyruvate. Any questions, students, here? Just ask me if you have some queries in your mind. Just ask. Yes, Hania, are you getting? Hania? Hania, you getting?
Yes, sir.
Okay. Navira is here? She's not here?
जी sir.
Yes,
Yes,
Navira. नवेरा, अब ये जो 5-6 पॉइंट्स हमने डिस्कस किए, मुझे 2 लाइनों में इसका सेंट्रल आइडिया बता दीजिएगा। अभी तक क्या पढ़ा हमने ग्लाइकोलाइसिस के हवाले से? जल्दी जल्दी। शाबाश, hurry up. I'm asking you, Navira, can you tell me where glycolysis takes place in the cell? Beta, I'm asking something. At least reply.
Sir, Navira going to class.
Okay. Right. Aisha Tasveer, you here?
Yes, sir.
Aisha, can you tell me simply where this reaction takes place?
Both.
And both. Good. Fine. Aksa, now I have a question from you. Aisha, please switch off your mic. Aksa, can you tell me how many ATPs are required? Do you think ATPs are required or not for the initiation of glycolysis? Aksa. Of glycolysis is
NADH, ATP, and pyruvate molecules. Sir, substrate. Sorry, मैं end products बताई थी sir. Substrate glucose.
Glucose, and the products are ATPs and ADPH and pyruvate, right? So, how many carbon are there in one pyruvate?
3.
3, right. So it means that at the end of the 6-carbon compound reaction, the glycolysis, our products are 2 molecules of pyruvate with NADPHs, ATPs. Right. Please switch off your mic now. And you can see my screen?
Yes, sir.
Okay. So now the next step. The overall reactions for glycolysis is now in front of you. You can see glucose, a 6-carbon compound that has been, if I use here a word NAD plus, and also here we should write here as 2 ATPs as well. I'm just going to correct this one because here NAD, and then we have also to write here as, because there are 2 different products, so that means this is another molecule. Right. So here, right. So NAD plus plus, it's not NAD plus plus. NAD plus is different molecule, and plus, that means it's another reactant. 2 ATP molecules. I mean, I'm going to a slideshow from here, from the current slide, and it's like this one. Yeah, now you can see here, 6-carbon of glucose, a 6-carbon compound. It has been hydrogenated or dehydrogenated. Faria, glucose is hydrogenated or dehydrogenated in this reaction? Yes, Faria.
Hydrogenated.
Glucose is dehydrogenated because glucose is oxidized here. And this NAD, you can see this NAD is hydrogenated because the product is NADH, isn't it? You can see here, NAD here is in oxidized form already, so it has been reduced as NADH. So from where this hydrogen has arrived, this hydrogen has been extracted from the glucose. So glucose has been oxidized, I mean dehydrogenated, and the resulting hydrogen has been added. अच्छा बेटा, आप लोगों को इन द मीन टाइम अगर कोई भी क्वेश्चन करना हो तो आप प्लीज, मैं आपके साथ हूँ, आप मुझसे पूछ सकते हैं किसी स्टेप में अगर कुछ समझना हो।
सर वो 2 प्लस कौन सा था? तो मतलब देख, तो NAD प्लस था और जो दूसरा प्लस है वो किसका है?
असल में ये कुछ भी, ये दो अलग रेट है, उसको सेट करने के लिए देखा गया है। ग्लूकोज के
अच्छा
साथ
अच्छा
दो मॉलिक्यूल NAD प्लस और फिर मॉलिक्यूल ATP भी, ये रिएक्ट, ये वो सबस्ट्रेट है जो ग्लूकोज के साथ, और फिर ये प्रोडक्ट्स हैं, ठीक है।
अच्छा, ये तो ये एंडरगोनिक है एक्सरगोनिक है?
ये तो आप बताया, ये एक्सरगोनिक हो सकता है या एंडरगोनिक हो सकता है।
एक्सरगोनिक आई थिंक।
आप देख, ATP बढ़ रही है या टूट रही है इस,
ATP बन रही है।
नहीं इस रिएक्शन, आप रिएक्टेंट क्या, रिएक्टेंट ATP है ना, तो आप ATP खर्च कर रहे हैं, जब खर्च, तो इस पे ये आप एज अ एंडोथर्मिक रिएक्शन के, यानी आप
सर
एक्टिवेशन।
सर आपकी आवाज बहुत कट रही है सर, आवाज बहुत कट रही है।
एक सेकंड में कर लेता हूं, आप सब ऐड कर रहे हैं, मैं कुछ चेंज करूंगा, आप मुझे बताइएगा। तब कोई बैक हुआ, आवाज आ रही है?
नहीं सर, हल्की, बिल्कुल हल्की सर, बिल्कुल हल्की।
मुझे लगता है इस सुनाएगा, क्योंकि मैंने तो वीडियो भी बंद हुई है। एक सेकंड में दोबारा कोशिश कर। जी, अब बताइए, कुछ बेहतर हुआ?
हाँ जी, अब आ रही है सही, अल्हम्दुलिल्लाह।
ठीक है, चले, तो मैं ये बात बताना चाह रहा था कि जरा प्लीज फोकस कीजिएगा। इस रिएक्शन में अगर आप देखिए तो ग्लूकोज के साथ दो मोल, ये तो ओवरऑल रिएक्शन है, तो इसको तो आप ये नहीं कह सकते कि एक्सरगोनिक है या एंडरगोनिक है, क्योंकि जो 9 रिएक्शन है ये सबका निचोड़ है। ओवरऑल रिएक्शन को आप ये नहीं कह सकते, इसके अंदर एक रिएक्शन थोड़ी है, बहुत सारे हैं। लेकिन अगर हम स्टार्ट को देखते हैं तो स्टार्ट में हमारे पास NAD जो है वो रिड्यूस हो रही है। इसका मतलब है ये जो ATP है, ये ये एनर्जी रिलीज हो रही है, ATP हमें चाहिए। जब भी रिएक्टेंट साइड पे ATP लिखी होगी, इसका मतलब है कि आप ATP को तोड़ रहे हैं, तो उस रिएक्शन को एनर्जी की जरूरत है, एंड दैट इज इन द फॉर्म ऑफ एक्टिवेशन एनर्जी। जी, समझ रहे हो?
जी जी बिल्कुल सही है।
चले, अच्छा मैं दोबारा अभी वीडियो वहीं से कनेक्ट करके चला रहा हूँ, आप फोकस कीजिएगा, ठीक है। Added to the NAD molecule to convert it into NADH, and some ATPs also have been used for this process. Getting? Faria, got it?
Yes, sir.
Okay, fine. Now, up till now, in the end of glycolysis, we will start now glycolysis in detail, but these are the summary of the entire process of glycolysis. So what is the summary? Once again, I'm going to tell you. Fine. Now, up till now, in the end of glycolysis, we will start now glycolysis in detail, but these are the summary of the entire process of glycolysis. So what is the summary? Once again, I'm going to tell you, glycolysis is the first step of the biochemical steps of cellular respiration, and it takes place in the cytosol or cytoplasm. It is a common step which is taking place both anaerobic as well as an anaerobic respiration. And so since it is taking place in anaerobic respiration, therefore it can take place even in the absence of oxygen. And what will be the substrate for glycolysis? The substrate for glycolysis is the glucose. And what will be the end product from glucose? We will extract ATPs and ADPH and the product of 2 molecule of pyruvate. Since glucose is a 6-carbon compound, therefore it forms 2 molecule of 3-carbon compounds called pyruvate. And glycolysis is therefore, this is a definition, is therefore a series of reactions that extract energy from glucose by splitting it into 2 3-carbon molecules called pyruvates. And the overall reaction for glycolysis is therefore glucose plus 2 NAD plus and then 2 ATP molecules. So 2 ATP molecules have been invested. It means at the start of the reaction, we need 2 ATP molecules. We do not produce ATPs immediately. Means you have to invest some sort of energy because no reactions can be proceeded without activation energy. So we need some sort of activation energy, and that activation energy will be provided by the ATP in the initial step of glycolysis. So when you want to convert glucose into pyruvate, you must have to provide some sort of energy, and that is in the form of ATP. However, we have consumed 2 ATP, but at the end in the product we got 4 ATPs actually. So we got a net of 2 ATPs. We have a profit of 2 ATP. We have consumed 2 ATP here, and we have a profit of 2 ATP because 4 ATP have been obtained from the oxidation of glucose into pyruvate molecule. And not only 2 ATP here, but we also got. जी हसन, कोई क्वेश्चन है बेटा आपका?
सर ये जो हमारा इक्वेशन है ये नेट इक्वेशन है ना, ये ग्लाइकोलिसिस की अपनी इक्वेशन नहीं है, सबकी चारों की मिला के, है ना?
ये ग्लाइकोलिसिस के अंदर टोटल 9 स्टेप्स है, जिसको अभी आप डिटेल में पढ़ेंगे. ये उन 9 स्टेप्स का निचोड़ है, नेट है.
ठीक है.
ठीक है
जी सर.
ओके. And if you remember, in the initial lectures I told you that one NADH has the potential to generate 3 ATPs later on in the aerobic respiration in the mitochondria. So if this process is proceeding further in aerobically in mitochondria, then this NADH will also be hydrolyzed to remove 6 ATPs. So 6 ATPs later on and 2 ATPs net gain here. It means glycolysis has the potential to add 8 ATPs in the total 38 ATPs of one glucose molecule. In the previous lectures I told you that one glucose molecule has the potential to generate 38 ATPs, and in these 38 ATPs, 8 ATPs from glycolysis, 2 directly net gain and 6 indirectly in the form of NADHs. Any question? जी यहाँ कोई क्वेश्चन तो नहीं करना आप लोगों ने. ये जो हमारे पास 4 एटीपी बने हैं ये डायरेक्ट बने हैं, जिनमें से 2 हमने खर्च भी किए हैं, तो इसलिए नेट एटीपी हमारे पास यहाँ 2 है. और हमने यहाँ 2 NADH के मॉलिक्यूल बनाए हैं, जो हमारा एंड प्रोडक्ट है ग्लाइकोलाइसिस का. ये जो 2 NADH हैं ये बाद में माइटोकॉन्ड्रिया में जाके इसमें से आपको पता है कि एक NADH से 3 ATPs निकल सकते हैं, तो 6 ATPs का पोटेंशियल हमारे पास यहाँ पर है और 2 ATP का यहाँ पर है, तो ये टोटल मिला के 8 ATPs बनते हैं. इसलिए हम कहते हैं कि ग्लाइकोलाइसिस के अंदर ये पोटेंशियल है कि वो 8 ATPs जनरेट कर दें. ठीक है बेटा. जी बेटा.
सर ये जो ATP एक्टिवेशन एनर्जी के लिए चाहिए होता है वो कहाँ से आता है? लाइक हम लोग को पता है कि ATP हम लोग के पास स्टोर तो नहीं होता है, तो इसको ये कहाँ से मिलता है?
Good, very good question. And you know that glycolysis and all respiration is a cyclic process. In a cycle, so when there is a cycle, we can't say which one is the substrate and which one is the product. It's just like the same question जब कोई पूछता है कि भाई मुर्गी पहले आई या अंडा पहले आया. So it means they are dependent from one another. I mean, respirations are responsible to yield ATPs. And some of these ATPs, of course, are required to start the process of respiration. So since respiration gives us more energy, so yes, we have a question then, when the first glycolysis in the beginning of life has been begun, from where these ATPs have been arrived, that's the case of evolution. It's a different question, we don't know. But we say like glycolysis can be initiated by ATPs and it will also produce later on ATPs, right? So now let's move to the next slide now. Now, let's talk about the steps of glycolysis. How many steps of glycolysis we have? Glycolysis can be classified into three major steps. Right. So, I'm just going to share attendance as well, first of all, because it's, I don't know, I have your attendance first. Let's move to the current slide here. On the current slide. So, I don't know. Scroll. Why is it broken? It's locked now. So now let's move to the current slide. Three steps of glycolysis. Glycolysis can be classified into three major steps. What are these steps basically? Number one, energy investment phase. As I told you that glycolysis cannot be proceeded without the use of energy, which is required as an activation energy. It comes from the ATP. So the first step of glycolysis is the energy investment phase. The second one is called sugar cleavage. Cleave का मतलब होता है break down. So sugar can be cleaved in the second stage. And of course the third is the energy yielding phase. So we invest here and then we got here. So we invested some sort of energy to cleave the sugar, and then we got the energy in the third stage. So glycolysis has three major steps: energy investment phase, sugar cleavage, and energy yielding phase. Right. Now let's move to the energy investment phase first of all. Energy investment phase. Energy is required to make glucose molecule reactive. As I told you that to make a glucose unstable or reactive, we need some sort of energy, and that is provided by the ATP. So glucose or hexose sugar, hexose means 6-carbon sugar, is therefore need to be phosphorylated. Now keep in mind, initially I told you that each and every molecule, if you want to make it reactive, you must have to add phosphate on it. So when you add a phosphate group to any one of the molecule, it becomes phosphorylated. And if this phosphate comes from some sort of like from the ATP or some other source, it makes the molecule unstable. So you want to make the glucose molecule unstable or more reactive. I mean, you want to prepare glucose for the reaction. Initially, 2 ATPs are required to double phosphorylate hexose sugar into 2 different reactions. So 1 ATP is not sufficient. We need 2 ATPs to phosphorylate hexose sugar. I mean, if you want to provide some activation energy, that's more than 60 kilojoule, because 1 ATP has only 30.5 kilojoule of energy. So we need 2 ATP to phosphorylate hexose sugar. Now the resulting molecule therefore is called hexose bisphosphate. This means 2-phosphate. So hexose contains 2-phosphate. You know in carbon, how many carbon we have in hexose? Of course, 6 carbon we have. So the phosphate group is attached to carbon number 1 and carbon number 6 of the sugar molecule, glucose, converted into hexose bisphosphate. Hania, you here?
Yes, sir.
Hania, can you tell me which molecule is more reactive? Sugar, glucose, or hexose bisphosphate?
Sugar.
If sugar is more reactive, then why we?
No, sorry, hexose is more reactive.
Yeah, because we have consumed the ATP to make it unreactive or unstable. Aisha Tasveer, which molecule is more unstable, sugar or hexose bisphosphate?
Hexose.
Hexose bisphosphate is more unstable due to the presence of these 2 phosphate groups, right? Now, in the next step, sugar is not only phosphorylated but also isomerized its structure to fructose before phosphorylation. Right. Do you have some idea of isomers in chemistry? Isomers have different structural formula. They have the same molecular formula, they have same number of elements, but they have different structural formula. Like fructose and glucose, both are monosaccharides, both have 5 carbon, 6 carbon, and C6H12O6, both have the same formula, but they have different structural formula. So it says that hexose sugar, I mean glucose, is not only phosphorylated but also converted to fructose. So isomers have different structural formulae and therefore bring changes in their bond energies to make itself more unstable in this case. Right. Faria, can you tell me which molecule is more unstable, glucose or fructose?
Fructose.
Yes. Do you think they have same formula or different molecular formula?
Same molecular formula, different structural formula.
So when you say different structural formula, I mean you are doing some changes in their bond structure. I think you have been told in chemistry. And you change the bond angles and the bond geometry, and there are some changes in their energy value as well. So when you are going to decrease the bond energy, then that molecule become more unstable. So